Hello and welcome students. In the previous video I taught you how to find. We found the nth order derivative of x raised to m. We found nth order derivative of x raised to m. And then there were three cases you saw. The first case was when the nth order n is equal to m. So when n is equal to m, the answer was n factorial. Then the next was you had n greater than m. Now, when n was greater than m, you saw that nth order derivative is 0. And finally, when n is lesser than m, for n lesser than m, what I said, this is the answer. This is the answer. Now, students, using what we did in the previous video, I'm going to now tell you we are going to get the nth order derivative of ax plus b raised to m. Okay, this is going to be the next question. Y is equal to ax plus b raised to m. What we have done? We have done y equals to x raised to m. So see, we have had variable raised to constant function, but the variable was x. Now what we are doing is this x we are replacing by linear algebraic in x. We are replacing it by linear algebraic in x, that is ax plus b. So let us see how is this done. This question is actually question number 4.1 from your exercise 1.5. See what we are given. Given y is equal to ax plus b raised to m. Okay. See, the things are going to go exactly the way you did for x raised to m. Okay. So here you differentiate with respect to x first time. Differentiating with respect to x, you will get dy by dx equals to derivative of this. What it will be? M ax plus b raised to m minus 1, and then derivative of ax plus b. It is ax plus b raised to m. It is f of x raised to m. So its derivative will be, what is d by dx of f of x raised to m? What it is? It is m f of x raised to m minus 1 into d by dx of f of x, that is f dash. Same way here, derivative of this will be ax plus b raised to m times ax plus b raised to m minus 1 into derivative of ax plus b, which is a. So what you are noticing, students, that this time along with these two, we are also getting a constant a being multiplied. Okay. See, next step, when I differentiate for the second time, what will happen? Differentiating with respect to x, when you differentiate, see, you will get d2y upon dx2 is equal to, now see this m, okay, and you are differentiating the whole thing. Try to understand. You are differentiating the whole thing. So this m and this a, they are constants, right? So I will write, let me write a first and then m, and then here I will differentiate this part. What will be derivative of this? It will be m minus 1. It will be m minus 1 ax plus b, ax plus b raised to m minus 2. Okay, into d by dx of ax plus b, that is again a. You have a again. Do you understand why this a is coming again? Okay, let me repeat this. See, students, when you are differentiating for the second time, you are differentiating this whole thing, right? So what is going to happen? This am we will write here, and then you will differentiate this ax plus b raised to m minus 1, which is f of x raised to n type. It is f of x raised to n. It is variable raised to constant, but look at the variable. You are differentiating d by dx of ax plus b raised to m minus 1. So it will be m minus 1 ax plus b raised to m minus 2 into derivative of ax plus b, and this a will come once again. So you have am and ax, wait, sorry, am, this constant and this constant, derivative of this, I will get m minus 1 ax plus b raised to m minus 2 into derivative of ax plus b, which is a. So you have therefore d2y by dx2 is equal to a square, a into a is a square, then m minus 1 ax plus b raised to m minus 2. Okay, this is number 1, this is number 1, and here you have number 2, second. Okay, now we will differentiate once again. So see, when you will go for differentiating once again, what will happen? You write here differentiating with respect to x. So you will have here d3y upon dx3. See, and derivative of this, what do you notice? You notice that in this part is complete constant. So it will come out. So you will write this as a square m minus 1 and differentiate this, okay, which is variable, this to constant. So it will be m minus 2 ax plus b raised to m minus 3 into derivative of ax plus b, which is again a. So what is it getting you? What is it now getting you? It is, you get here a cube, see the third order derivative is a cube, a square into a cube, m minus 1, m minus 2 into ax plus b raised to m minus 3. This is what you get. So the next step, so in the next step, as you understand, I write this as 3. This is 3. If I continue like this, say if I continue the same process, so what will I get? I will get the nth order derivative. I will get dny upon dxn as, see, you can now understand, when you have first order derivative, you have a power 1. You see this? When you have second order derivative, you have a power 2. You see this? When you have third order derivative, see 3 here, you have third a cube. So what I understand that if I have nth order derivative, I will have a raised to n for sure. For sure, I'll have a raised to n. Okay. Next. Now next, I understand that m minus 1, m minus 2. See, when I have second order derivative, see, I have m multiplied with m minus 1. For the second order derivative, I have m multiplied with m into m minus 1. Then for the third order derivative, it is m minus 1, m minus 2. So I understand that it is going in decreasing order, m minus 1, m minus 2. I'll keep writing one lesser number in decreasing order. And the final bracket which I will have, it will have m minus a number which is 1 less than this. Okay, see here, the last bracket you have, it is m minus 1 lesser than this. It is 3, so you subtract 2. So same way here, if it is n, you subtract n minus 1. So m minus n minus 1, m minus n minus 1. Okay, bracket close. And then ax plus b raised to m minus n. This is what I get. So the nth order derivative, you will have dny upon dxn is equal to a raised to n m minus 1, m minus 2, m minus 3, and so on, m minus n. Let me open the bracket, m minus n plus 1. And here you have ax plus b raised to m minus n. This is my nth order derivative. What I'll do is, in this, see, from here till here, I notice that I have numbers which is in decreasing order, and this is consecutive decreasing order. That is, each time you have one less number. So I understand that if I keep continuing this, then I will reach, you know, this is some number, then one less, one less, one less, one less. So if I keep writing one less, I can reach to one. What will happen? Whatever number you have, if you keep writing one less, then you will finally reach to 6, 5, 4, 3, 2, 1, like that. Okay. So you know what I do? In order to make it my own way, that is, in order to make it a factorial notation, see, in the next step what I do. This is a raised to n, and here I write m minus 1, m minus 2, m minus 3, okay, dot dot dot, m minus n plus 1, and then see, then I multiplied with it. I multiply m minus n. See, 1 less than this is this number. 1 less, 1 less. You see this? 1 less. Let me come to the next line. Then m minus n minus 1, m minus n minus 2, and so on till I get 3 into 2 into 1. Okay? And with this what I have? With this what I have? I have ax plus b raised to m minus n, that I have. And whole divided by, I divide the whole thing by what? Yes, what I multiplied, whatever I multiplied, I will also divide by that. You see this? So in the next step, see what I get. I get here m minus n, m minus n minus 1, m minus n minus 2, and so on, 3 into 2 into 1. So the next step, what we have, students, we have dny upon dxn is equal to a raised to n. The numerator you can check this, it is starting from m and it is going up to 3 into 2 into 1. So it is m factorial into ax plus b raised to m minus n Okay, and divide by what? This is m minus n factorial. M minus n factorial. This is m minus n. This is m minus n factorial. This is what I got. And when is this? This is actually, this is, you can take this as case 1. Okay, you can take it as case 1. That is when n is less than m. When n is less than m. This is case 1. You can write here case 1. Yes. When n is less than m. That is the power which they give. Try to understand. When I say n less than m, it means the power which they give is greater than the order you are finding, the order derivative you are finding. N is less than m. What are we going to do next, students? We will take case 2. In case 2, I will take case 2, that is n equal to m. Now, when n is equal to m, here everywhere for n you will write n. So you have dny upon dxn is equal to a raised to n. This is n factorial. M minus n becomes n minus n, which is 0. This will become 0. Power is 0, so 1. And n minus n, again 0 factorial is 1. So the final answer is a raised to n into n factorial. This is case 2. And see, the nth order derivative you are getting is a 0. What do you see? I'm sorry. Nth order derivative you are getting is a constant. It is a constant. There is no x in this. You are differentiating with respect to x. So this is a constant. So when you will differentiate once more, you differentiate once more and the answer will be 0. So case 3. Case 3 is when n is greater than m. That is, the order derivative you are finding is more than the power of ax plus b. Than the power of ax plus b. So what you will get in this case, you will get dny upon dxn. You know, when you have differentiated n times, you got this. Now you are differentiating once more. Okay? We're differentiating once more. Like if suppose this is 10, if this is 10 and you differentiate it 10 times, what you will get? You will get answer as a raised to 10 into 10 factorial. Now tell me, if I ask you to differentiate once more, what does it mean? It means you are going to get the 11th order derivative. And what will 11th order derivative is? 11th order derivative will be 0. The answer will be 0. This is third case. I hope you followed it.